Hello students, welcome in our chapter 6 AOD part 3. Yes students, today I in part 3 continue our exercise 6.1. In the question number 15, find the cost Cx in the rupees associated with the production of X units, and the given item given by the Cx, that is the one of the polynomial equation, and asking find the marginal cost when 70 units are produced. Very easy. Marginal cost means nothing students. This is the value given for cost by Cx. You take the derivative with respect to their variables. Then you take in. These are marginal cost. At the unit 17. It's very easy. I just start differentiation with respect to the variable x and apply easily your derivative. So your ddx of cx means our cx value. Here ddx of our whole question 0.007, 0.003 x square and 15x plus 4000. You know the derivative. Yes. 0.007, this derivative is a 3x square. Next, 0.003 into 2x, 15. X is 1 and 4000 is a 0 because constant. Now, marginal cost ready. This equation is what? Your marginal cost. At which place? 17 units. Means you just taking out x is equal to 17 and that value you put down in place of x is 17. So 0.007 3 into 17 square minus 0.003 into 2 into 17 and here 15. Now students, we utilize calculator. Simple calculator you allowed here and you calculate and easily getting one of the written answer. So which is a 20.967 rupees. That's your our marginal cost of given Cx at the unit x is equal to 17. Now students, I am going ahead question number 6. Now students, same copy question. After that now given Rx. Revenue is given. So total revenue in the rupees received from the sale of X unit and produced is given by Rx. Some equation given 13x plus 26x plus 15. Find the marginal revenue. Marginal revenue means you take the derivative with respect to X of given revenue equation, and when at x is equal to 7 units, at that place 7 unit I after derivative put down and we get answer. So differentiation with respect to x. So ddx of our revenue Rx. This side also ddx of your question 13x square 26x plus 15, and here you just take out simple derivative. So 13 into 2x plus 26 into 1 plus 0. Now at x is equal to 7, your answer marginal revenue. Yes, marginal revenue is only put down 13 into 2 into 7 plus 26, and when you calculate total value is your answer is that how much? Yes, answer is given 208, and that's your final answer. Either you calculate 7 to the 14, 14 into 13 plus 26, and total answer 208. after ending our 16 question, there is a two little MCQ coming, 17 and 18. Question is that rate of change of area of circle respect to its radius changing at the place r equal to 6. It's very easy. This is your circle and here your radius. In initial radius is given that it is 6 centimeter and given that radius respect to change, respect to its radius. It means area of circle with respect to radius is my target. dA by dr. Now area of circle which is a pi r square. You know very well and start the derivative. Differentiation with respect to this respect to. Always read the question properly. R respect. So dA by dr, here d by dr of pi r square, and which is what? Pi into 2r into dr by dr. So finally finish. dA by dr 2 into pi into what is r? 6, and dA by dr is 1. So 12 pi. Unit must be write down centimeter square per centimeter, and that's your finally answer, which is 12 pi. That one. It's very easy sum. Now we are going to question number 18 MCQ. Now students, after ending our question 6-17, I go to 18, also same question, asking that total revenue in the rupees received from the sale of X unit product in the given by X. These are equation given already, either polynomial for revenue wise, and asking marginal revenue at X is equal to 50. Again do differentiation with respect to X, and the options is given very easy. So dx of your revenue X. Same thing, derivative right side, ddx of 3x square 36x plus 5. So here getting 6x plus 36 x1 5 constant. Now add x is equal to 15 units. What is given? Marginal. The applied revenue. You just put down x value is what? 15. So 6 into 15. 15 given no? Plus 36. Yes, 15 6 and 36. You just both added, you getting 126. Yes, 90 plus 36. 126. This rupees your our marginal. Now students, after this exercise 6.1 ending, I start our illustrations. Yes, illustration is remaining to related our this 6.1 exercise. Now students, I slowly going our examples. First example, find the rate of change of area of circle with respect to, yes, with respect to its radius when r equal to 5. Very easy. This is your circle. And here we want the radius 5 cm initially, and my target area with respect to radius means if r equal to 5 cm, then my target achieve dA by dr. Yes, that's your first thinking in your mind. Respect to radius, not time. Huh? So area of circle, you know that, yes, very well. And differentiation with respect to r. So dA by dr, d by dr of pi r square. Applying systematic derivative with respect to r. So here pi into 2r, but r respect to r 1. R you know 5. It means pi into 2 into 5. Your answer is 10 pi. dA by dr and unit centimeter square per Radius means centimeter. And that's your simple, cute answer. Now, question second. Example 2 students already have written here questions. So don't worry, I just read out that volume of a cube increase at a rate 9 centimeter cube per second. Per second, it means you focus on the time. Time respect, you take the derivative. How fast surface area increase at the edges is given 10 seconds. So students, first of all, you just draw one of the little drawing here, cube. All sides equal. It is a 6 sides, and all 6 sides is your what? Square. And here side is x consider, which is 10 centimeter given. Here write down volume V, which is x cube, and surface area, it is A, which is 6x square. That's your question. According to formula, I just applied it. Now, if x is equal to 10 cm, then what is the target? Surface area changes. dA by time. Time means second. Here given time dt. Sometime minute also given, so don't worry about it. You just apply dt versus derivative. And easily going. Given here volume increasing means dV by dt given. How much? Which is 9 centimeter cube per second. And this is your given data. Now I start volume given. So volume side start. Volume of cube, which is V, x cube, and start to derive with respect to t. Differentiation with respect to what? Respect to t. So dV by dt, d by dt of x cube, dV by dt known. But before putting the value, you must be checked. This centimeter and this centimeter are same unit. Otherwise, convert in the same unit. So here your answer is 9 3x square dx by dt. Now 3 are gone. I have only 3 is equal to what is the x? 10, which is 10 square dx by dt. So you can go in here dx by dt. It means edges changes, side changes respect to time. It is 3 by 100 centimeter per second. Every second, this length of edges of the cube increase per second. 3 by 100. And my target, surface area. Yes, now I start surface area related derivative and easily do the derivation of respect to time. So surface area, which is A, 6x square. Here also differentiation with respect to time. Yes. This is a main point with respect to checking already given in the question. So here dA by dt, 6 outside. d by dt of x square. So students, first answer dA by dt 6a. And what is the x square? Yes, it is 2x. dx by dt, and that you know 3 by 100. It means dA by dt you easily know 6 into 2, what is x? 10, and it is 3 by 100. Easily 0 cancel. 6 to the 12, 12 3s are 36 by 10 centimeter square per second, 3.6 centimeter square per second. This is surface area change respect to time. It is 3.6 students, and very easy. But this numerical is IMP exam level because volume utilized, surface area utilized, both way you asking in exam. Sometimes surface area given and asking the volume increasing. So you calculate by surface area and depend on question volume defined. Okay. Now next one. Now students, I am going ahead. Example number 3. and then after 4. Third is a stone is dropping into quiet lake and waves move in the circle at the speed 4 centimeter per second. Means it is a radius increase per second 4 centimeter. At the instant when the radius of the circular waves is given 10 centimeter, then how fast enclosed area of the circular part. So students, this is your concentric circle. If you dropping a stone in the silent water, yes, here the radius, this radius, every second the radius is changed out. How fast? 4 centimeter per second. It means dr versus dt, you given that 4 cm per second is changed, and asking dA versus dt at position radius given how much? 10 cm. Yes, at the place of 10 cm. Asking that how fast enclosed area change, because area is changing, because the radius is changing with respect to per second, it means time. So area of circle, it's very easy, pi r square. I take differentiation with respect to what? Time, not respect to radius, respect to time. So dA versus dt, pi d by dt of r square. It's very easy. 2r, r relative, dr relative, and that much is given, and that is my target. So dA by dt, which is pi into 2, what is the r? Initially 10, and dr by dt 4. You need to check. Same. So your answer is 4 to the 8 to 10. Yes, 85 centimeter square per second. Every second area is changing 85 centimeter square. Yes, students, it's a very easy question. Now students, I slowly moving ahead. Question number 4. Fourth also IMP questions. Length of rectangular is decreasing at a rate 3 centimeter per minute. Students, this given decreasing, it means you take out minus value, and width, it means breadth, increasing at a rate 2 centimeter per minute. It means you take out plus 2. And if x10, y6, then changing parameter. And what is the changing area of rectangle? Very easy. I just first of all draw for your better understanding one of the A, B, C, D rectangle. X length taking, Y breadth taking, and it is given that 10 cm initially, and breadth given it is your what? 6 cm initially. And question read one more time necessary. Length of rectangle is decrease. It means dx versus dt. Decrease means what? Minus. Given that 3 centimeter per minute, and dy by dt, it means breadth, broadness, the given increasing. Here increasing word given, so I just taking plus 2 centimeter per minute, and asking the two little questions: parameter changing and area changing. I start first. Parameter of the rectangle. You know that parameter P, 2 side length, 2 side breadth, it is 2x plus 2y, and differentiation with respect to minute given, time given, so t. Yes, students. So d of p versus d of t. 2 times dx by dt, 2 times dy by dt. Successfully applied your value. 2 dx by dt is a minus 3. Yes. Plus 2 dy by dt plus 2. So minus 6 plus 4, which is minus 2 centimeter per minute. And that's your given. Parameter is changing If you length change -3 per minute and breadth change +2 centimeter per minute, then perimeter change -2 what? It is decreasing. Yes, here answer written. Perimeter decreasing 2 centimeter per minute. Now let's start. Second position, rectangle area. Yes. Now area is changing. To given that very easy. You just think about area of rectangle. Definitely known length into breadth. So area, second point, area of rectangle. A, length into breadth, which is x into y, and here time persists. I start my derivative. So differentiation with respect to time. So dA by dt. Here product rule apply. First, second derivative, second, first derivative, and all value known. Just putting down one by one. X is what? Tan semi initial rectangle length. dy by dt 2. This one. Plus y is a 6, but dx by dt is a -3. So your value dA by dt, it's very easy. It is 10 to the 20, 6 3 are 80. My answer is 2 centimeter square per minute, and that's your final answer dA by dt. Students, here area is increasing per minute 2 centimeter square, and parameter is decreasing. Properly write the word decreasing because -2 centimeter per minute. Now students, I going ahead. Question number 50. Now students, one more repeated questions. Example 5. The total cost Cx given in the rupees associated with the production of the x unit of an item is given by Cx. These are equation given, polynomial equations, and find the marginal cost when x is equal to 3 units are produced. So very easy. Marginal cost, you take out derivative respect to x. So I just start differentiation with respect to x. So students, here d by dx of Cx, same here, d by dx of your whole question 0.005 x cube minus 0.02 x square 30x plus 5000. Very easy. You take out the derivative properly. What is the x cube derivative? 3x square minus 0.02 x square derivative 2x 30 x derivative 1 and 5000 is a purely constant. Now read one more time. Marginal cost when x equal to 3 units means x is equal to 3 units. Our marginal cost ready. Only just I apply x is equal to 3. So 0.0005 into 3 into 3 square x plus apply 3 minus 0.02 into 2 into 3 x plus apply 3, and here going easily you 30, and after that utilize calculation. You just calculate your further solution. So using calculation you get the answer 30.015 rupees, and that's your students for finally our marginal cost at the place of x is equal to 3. It's very easy sum. Now parallel questions, one more students. Example 6. The total revenue in rupees received by the sales of x unit, and given that revenue x in the quadratic equations 3x squared 36x plus 5, and asking what is the marginal revenue at x is equal to 5 units. Very easy. Same going, I take derivative, differentiation with respect to what? X. So d by dx of our revenue Rx derivative. Same as right side also. It's a ddx of your right side value 3x square 36x plus 5 and take simple derivative. So here it is 6x plus 36y plus 0. So x is equal to how much? 5 units. Yes. 5 units our marginal revenue. You just apply x plus 5. So here apply yes 6 into 5 plus 36. 6 5 is 30. 30 plus 36. It is 66 rupees. Your marginal revenue. It means your revenue given equation, take derivative, marginal revenue. If you cost is given, derivative, it is the cost revenue. Yes, marginal cost. Yes, students, here our example 6 and 5. Our this topic is ending here. Exercise 6.1 and example 1 to 6 here. One little question. Our increasing data and decreasing time. One short topic is done. Students, after that I start in this chapter 6.4 exercise. Yes, students, in this chapter scenario 6.1 first I explain you successfully. After that 6.4. Then after I start 6.3 and after that I explain you 6.2 for easy and better understanding for this chapter. So you don't worry about that. Why sir is not started 6.2? Yes, students, it is easily explanations and easily going. I start 6.1, after that 6.4, then 6.3 and then 6.2. Okay, so don't worry. Clear? Now students, here this part is ending and after that new parts I continue in 6.4 with new topic. Okay, bye bye, see you.